Hey students, we're gonna do a technique today called Think Aloud. And you may have done this in some of your other classes, but what we're gonna look at is a reading. And as you go through the reading, when you read stuff, you shouldn't just try to read it and not do anything with it. You should be having some thoughts in your head and jotting down some things. And this helps you process whatever you're reading. So the Think Aloud, we have a worksheet that goes with this. The big goal in the end is when you do this enough, some of these things will become more natural to you and you'll start doing them in your head. But right today, you're gonna be asked to do this and write out at least 2 sentences for each question. So I'm gonna go through the questions with you first so that you kind of know what you're thinking of, and then we'll start looking at the reading together, and then you can do the rest of the reading yourself. So the questions that are gonna be asked for the Think Aloud are, the first one is, what does this remind you of, look like, or sound like? And when you're writing your sentence starter, you can use your sentence starter like, this is like, and write something out, or this reminds me of something here. Second Think Aloud question is, what does the information provided look like? What is the text trying to say? Can you draw a picture to help you visualize? So you don't have to just actually draw a picture, write a sentence, but if you picture something, say, I can picture this happening, or I see this happening, or something like that. So this is kind of a visualizing step, what you're seeing based off of what you're reading. The third one is, do I have questions I'm confused about or I'm not sure of? So these could be whole blocks of text that you're not sure of, or if you have something that's mentioned in the text and you're not sure about that, go ahead and write a question down. It's like, I'm confused about this, or I'm not sure why this is happening. If it's just a word, you can also just have singular words, and you can write those down. What is the purpose for reading, and what is it trying to teach or explain to you? And this is more of a summary type question at the end. So when you're getting to the end of it, you can jot down, well, this is what I think it's saying, or what's I think it's explaining is something like this. And then finally, after you're all done, some kind of reflection. I realize that this might be happening, or I wonder if something like this is going on. Okay, so I'm gonna start looking at the reading. This is our reading here. It's ice versus water, density matters. And immediately when I look at this title, I can see 2 pictures. I see ice. It says hydrogen bonds are stable. And then it says these are hydrogen bonds. And then this is liquid water. Liquid water, hydrogen bonds constantly break and reform. And so as I'm going through, you can jot down some stuff. I see density, and I remember, well, we did some stuff in the beginning of the year and last year, density. I remember that stuff that has to do with floating. I don't know if you remembered the soap experiment. So we had some soap experiment where something that was, I think it was, if it's less dense, it floats. And if it's denser than water, it sinks. So less dense was floating, and then denser was sinking. Okay, so, and I look at this picture here. Wow, I see some dashed lines. And maybe this reminds me of something in our unit. So I could even write down right away, say, well, this is these hydrogen bonds I see hydrogen bond here. Maybe I want to write down a hydrogen bond. This is kind of like something I saw in the unit, or I don't know, maybe it reminds you of something, okay? So I'm gonna keep going on here. Mark Schneider. The average ice fisherman isn't contemplating density of ice versus water while jigging for walleye. Okay, I know walleye is a type of fish. Water is unique because its solid state ice is actually less dense than liquid phase, allowing walleye and other aquatic life and the ability to survive underneath the ice in cold but unfrozen waters each winter. So I'm seeing a couple things here. I just saw this less dense. Well, we wrote something about less dense up here. Remember, less dense is floating, and it says ice is less dense. So that's kind of odd. That's unique. Unique is, special. Something special about water. I look at solid state ice, and I'm gonna look at this picture here, and I see it's less dense. I also see that, well, this picture is kind of, they got these, looks like a honeycomb, right? It looks kind of like a bee hive or something. It's a honeycomb. Reminds me of bee honeycomb, if you ever see that before. This looks more kind of jumbled up, right? So I'm gonna write jumbled. But now it's this first paragraph is already starting to talk about this is less dense. Okay, let's just keep going on here. So walleye, and it looks like walleye and other aquatic life survive underneath the ice. So I know that walleye can't. If they were in ice, they would freeze. But if they're underneath the ice, that means we have some unfrozen water there. So maybe I'm picturing this one here. So this, the first picture, I might even say hydrogen bonds. Hydrogen bonds reminds me of ... something in the unit that maybe you're picturing. Right now, I'm picturing this fish. So I can picture some fish, walleye, and some other aquatic life maybe surviving underneath here. So this, I can picture, and maybe you can write about the fish underwater, and ice on top, right? It looks like this solid state ice is on top of the water, okay? And then it says density. So that's already a couple things that I can do in the first two boxes. Density is equal to mass per unit volume, and can be changed by either increasing or decreasing temperature or pressure. Okay, so maybe this is something that, how does that happen? I don't know. I can put a question mark by it. When we freeze a liquid, we lower its temperature and become solid. Okay, we know that. The solid state of other liquids are denser because the molecules pack together tightly when the kinetic energy decreases. Oh, we know that term, kinetic energy and temperature. So it looks like other liquids are denser when it's solid. But here, so now I'm wondering, why does water have less dense? Okay, so I can see that other liquids are denser, but water is less dense when frozen. So water is less dense when frozen. So maybe, I can write something about that somewhere. So as you're going through this, jot down some notes, go through and see what you can picture. If you have questions that are coming up, for instance, in the next section here, it talks about, I can see already there's some stuff about, oh, it says pictures in the diagram. Positive hydrogen atoms are attracted to slightly negative oxygen atoms. Maybe you have a question about how these things become different charges. Maybe I have a question about words that I see. There's some words in this section that might be confusing to you. So go through this and jot down at least 2 sentences for each one. Okay? I want to see that you're having different thoughts than the people around you, so you don't have all the same thoughts, because that means you're probably copying each other. But go through it, jot that down, and then when you're done with this and you have everything, then do the reflection at the end. So make sure the reflection, I wondered what happens this, or I realized that something else is going on. Okay, and then we have a crossword that you can do if you have some extra time, but make sure you take some time on this. I will look at it and enter it into Student Connect. All right, have a good day.